Hello everyone. As we are preparing for our upcoming prelims examination, I am dedicating this particular video to one of the sections that I have not taken in the approach towards preparing some of the important part of physical geography. I am essentially talking about the oceans. Taking the base of NCERT 11th standard, we will be learning what exactly the hydrological cycle is all about, number one. Number two, the submarine topography, which is also called ocean bottom relief. Number three, what are the fundamental physical properties of ocean water, namely temperature and salinity. We can expect a question or two from this particular topic of our NCERT. It's very elementary, but it's crucial, because I have always maintained in physical geography, the number of questions in our prelims examination have been continuously reducing, barring the exception of some decent share of climate and climatology. And whenever we are touching the bottom, there is no other way but to rise up. And that is what we are sincerely following for our 2020 prelims. We know we are in uncertain times. We don't know what exactly is stored for us for the coming month or so. But it is always advisable to be at home and definitely preparing and not leaving it to what the final outcome will be. So take good care of your health, be at home and try to utilize the support that I am extending from my side, along with what we are already attempted and what will be eventually attempting. So without wasting much time, let us go to this study of very basic, the oceans, its physical characteristics and ocean bottom relief. Right, we are beginning with our chapter water, the oceans. As I said, we want to devote certain time to understand some fundamentals about it. The chapter begins with a very brief details. If I just read out a part of it, that Earth fortunately has abundant supply of water and hence our planet is called blue planet, very commonly referred and identified aspect. Now, if I have to talk about water in slight more details at a very elementary level, its hydrological cycle. Before I proceed further with hydrological cycle, which reads in our NCERT, water also undergoes a cycle from the oceans to land and land to ocean. The hydrological cycle describes the movement of water on, in and above the Earth's surface. As geographers, when we talk about hydrological cycle, we actually believe in three types of hydrological cycle. One is called atmospheric hydrological cycle, two is called daily or diurnal hydrological cycle, and three is called delayed or elongated hydrological cycle. Delayed or elongated. What exactly is the difference between the three? To understand it, you need to take the reference of what is coming up from NCERT itself to begin with. It reads that the water cycle has been working for millions of years, and when I take the distribution of water on the Earth's surface, which is quite uneven, it gives me the reference of circulation of water. Hydrological cycle is circulation of water within the Earth's hydrosphere in different forms, liquid, solid and gaseous phases. So how do I distinguish between the atmospheric hydrological cycle? Utilizing this space, I will say precipitated water from the base of the cloud is getting re-evaporated before reaching the surface. This will be the example of atmospheric hydrological cycle, essentially involving the phenomena called adiabatic warming, that the falling moisture from the base of the cloud before reaching the ground is getting adiabatically warmed up and thus is subjected to re-evaporation. Warmer climatic location experiences it. If I have to talk about diurnal or daily hydrological cycle, we largely experience it in equatorial climate. Basically, in equatorial climate, we identify forenoon evaporation, leading to afternoon precipitation. So, nutshell equation here is that what is getting evaporated and is moving to the realm of our environment called atmosphere is returned back the same day. So, equatorial climate essentially relates to what is called daily or diurnal hydrological cycle, where water vapor is returned back to the source in form of precipitation the same very day. And what is meant by delayed or elongated hydrological cycle? For this, I want you to see this NCERT image first. Penetration to soil, underground flow. Once the water percolates, I am talking about precipitation, water percolating to nourish subsurface aquifers. By default, it will not be returned back in the process of evaporation that swiftly. So, will it not be the example of delayed hydrological cycle? So, delayed hydrological cycle basically will relate to the percolated water, number one, and number two, the water that is falling or the precipitation that is falling in the snow field, because in both the cases I will not be having a swifter evaporation altogether. To prove it further, let me quickly add one more diagram. Kindly notice this diagram. This diagram is also of hydrological cycle with slight enlargement. Water storage in atmosphere, number one. Water storage as groundwater, number two. Water storage as fresh water, number three. Water storage in ocean, number four. And number five, water storage in ice or snow field. So, now we are taking the 5 areas of water storage. Water storage is correlated with 5 areas. Focusing on our diagram again, which are the storage of water in atmosphere, in groundwater, in fresh water, in oceans, and also in snow and ice. Now, if you just try to take reference of it, water from the ocean is readily getting evaporated. Water which is coming from the surface runoff, I can see it here, is getting evaporated. But the water which is getting infiltrated, once is out on the surface as spring, it will be subjected to evaporation. But if it is underground discharge and it is not having any outlet, like in this particular block, by default it will be delaying the hydrological cycle. Similarly, when I talk about this storage number 5, so I am insisting in our diagram storage number 2, which is groundwater, and storage number 5, which is ice caps. What exactly is happening? I have got 5 storage of water. The 3 other storage, namely in the oceans, highlighted here. Number 2, in the entire block that is correlated with atmospheric water, whichsoever water we are taking there in terms of condensed particles or in terms of water vapor, and freshwater sources. So, 3 of them in ocean, freshwater and atmosphere is not relating to what we call delayed hydrological cycle. Where do we apply delayed hydrological cycle? Delayed hydrological cycle is correlated with groundwater and ice caps. Now, carefully notice this table of our NCERT, and can you notice the components and the processes of water cycle. Now, components ocean, components atmosphere, storage in snow and ice, storage as surface runoff, read it as fresh water from our previous diagram, and groundwater. So, how many components we are having? We are having 5 components, 1, 2, 3, 4 and 5. With how many we take delayed hydrological cycle? We take it up with number 3 right here, and we take it up with number 5 right here. And if you try to pick up the processes involved, so in ocean I have got evaporation, evapotranspiration and sublimation, because I do have oceans with the frozen arm. In atmosphere it is condensation and precipitation. That is the reason I said a water storage in atmosphere can include both condensed particle as well as water in its vapor form. Water storage in snow and ice a snow melt runoff to the stream, so I have to wait for it, and same goes with groundwater discharge spring. Groundwater discharge as springs or in the open ocean will facilitate its evaporation, not before that. And the stream flow freshwater storage infiltration are the processes which is involved. So, what exactly I am deriving out from this table? I am deriving out from this table that the components and processes of hydrological cycle or water cycle includes 5. The storage that we attempted in the previous diagram, and the processes. What you need to understand with the processes is water cycle incorporate not just evaporation, evapotranspiration, sublimation, condensation, precipitation. It also incorporate melting of ice, snow melt, ablation. And it also incorporate the storage infiltration, percolation. You have to understand these expressions very clearly. All these combines to give us the component and processes of water cycle. Added to it, there is a table in our NCERT. I just want to emphasize on it. We have attempted the test question on it also. Now, water on Earth's surface, we should be aware of it. The reservoir of water, 97% plus is in ocean, and following that it is in ice caps. So, what will be the process that will make availability of water in atmosphere? Essentially, we are talking about evaporation and also to some extent sublimation. Once I add the reference of biotic components that are there in the oceans, I can also talk about evapotranspiration. So, relate them. And when I talk about ice caps, glaciers, groundwater and ice caps, glacier with groundwater, so I am numbering them. Oceans are accounting for 97% plus, ice caps and glacier approximately 2%. Rest all of them can be counted as others, and we attempted the question groundwater, lake, soil moisture, atmosphere, streams and rivers in decreasing order of the reservoir of water on the Earth's surface. So, oceans and ice caps have got the maximum share. Of course, when I compare them, oceans accounts for near all. Quickly remind yourself, NCERT tables, and NCERT tables are giving us the reference of the details. Let me zoom it out here. About 71% of planetary water is found in ocean. Remaining is held as fresh water in glacier, ice cap, groundwater, lake, soil moisture, atmosphere, etc. Nearly 59% of water that falls on land return to atmosphere through evaporation. Statement number 2, statement number 1. From the ocean as well as from the other places. The remainder runs off on the surface. Statement number 3. Infiltrate into ground and become part and parcel of the glacier. So, notice the statement number 3 is giving me the reminder of delayed or elongated hydrological cycle. Quickly repeating what we have taken and zooming in the important tables that we should take into consideration, which are the important components of water storage for the planet Earth. It's 5. And where do I apply the delayed hydrological cycle? It is with groundwater and it is with the snow and ice. And if I take a comparison of it in terms of their geographical extension, then I need to understand that oceans, ice caps and groundwater. So, ice caps and groundwater comes up as second and third in terms of its share of the total Earth's water resource. So, they are significant constituent. This is part 1 from this chapter. Now, part 2 of the chapter talks about relief of the ocean floor, and relief of the ocean floor is to be studied in reference to what are the features that we apply. So, our NCERT reads the oceans are confined to the great depressions of the Earth's outer layer, And we take the divide, the geographers have divided oceanic part of the earth into 4 oceans. Now it has been changed as 5 oceans, so you should be aware of it. Atlantic, Pacific, Indian, Arctic and Southern Ocean. And when I talk about these 5 oceans with their various sea bays, gulfs and other inlets, we are talking about submarine feature. So how do I distinguish submarine feature? What is the way I can demarcate submarine feature? Let us try to understand it with this. This is the general sequence of the submarine topography I will be noticing. Labeling them, this is called continent crust. This is called shoreline. This is called coastline. I have already said this is mean sea level. Mean sea level is identified to be the mean between the high and low tidal level. From the mean sea level, the depth of ocean floor is approximately 4,000 meters. This part, this is called continental shelf. This is called continental slope. And this is called deep sea plain. And what is there in front of us can be further demarcated as these two will be called continent margins. What is the reason they are called continent margins? Is that they do incorporate granitic, lighter density material made characteristics. And what is deep sea plain? It is true oceanic crust that is made up of basalt. So, it is basaltic crust. And it is in this consideration that we take the reference. This is what offshore. So, offshore is submarine feature and onshore is land feature. So, what are the major constituents that I talk about? Ocean relief. So, ocean relief will include, or submarine feature, submarine below the mean sea level will include number 1 continental shelf, number 2 continental slope and number 3 deep sea plain, which can also be called abyssal plain. Now, after learning it with a very simple sketch, let us take a diagram which will give us the understanding of the things much more elaborately one by one. Then we will go to our NCERT. Continental crust right here, this will be continental shelf. Continental shelf is paving way to, this is my shelf margin, this will be my continental slope, right? And continental slope is paving way to right here. What is this bottom called? Abyssal plain, as we referred just few minutes back. So, which are the 3 major physiographic units? It's continental shelf right here, continental slope here and deep sea plain here. But the point is that I am noticing there are so many other features for me to understand. Like if I see on this part of the figure, I do see a very narrow shelf, then a steep slope, and right here, this is my shelf and this is slope. If I just try to make it 3-dimensional, this will be continental shelf. This is my continental slope, and can we notice that there is a deep submarine trench? This submarine trench is the outcome of subduction. So, how to adjust all these features? I can notice mid-oceanic ridge right here. Can you notice these mountains in this ocean bottom? And are we noticing that some of them are actually ejecting out over the water surface, developing volcanic islands? So, how exactly we try to justify these relief features? We try to justify these relief features one by one in details like this. Please notice this figure. Are we noticing right here there is the active divergence taking place due to the mantle convection. As the crust tends to spread, zooming it here, as the oceanic crust tends to spread, it develops submarine ridge. These submarine ridges develops as and how the plate diverges, creating what is called mid-oceanic ridge or simply the ridges. So ridges will be feature number 1 in the ocean bottom. Feature number 2 in the ocean bottom can be correlated with this. Now we are moving towards our east and there is this mantle plume. Continuous ejection of magma that I can notice right here. Plate is moving towards east and continuous transit of plate over this hotspot. So note these are being marked up as extinct volcano. So if I go past in time, this number 1 was placed here. Because plate is drifting over the mantle plume, they are continuously developing volcanic island over and above water surface. This is an active volcano, hotspot volcano, and these are the extinct one which I am shading. So feature number 1 that I have noticed in ocean floor will be ridge. Feature number 2 that I will be noticing will be hotspot volcano. And what will be the feature number 3? Feature number 3 will be as I continuously move towards continental crust, I being heavier because I am made up of basalt. I am basaltic crust. I will subduce, this is subduction. I will subduce underneath the lighter density crust, that is continental crust right here. You can see it, it is written here, this is continent crust. There will be this subduction which will result into development of number 3, ocean trench. And this subduction will create not just the oceanic trench, note it will create the active volcanic mounds. We call them the island arc, and the island arc are being named as festoons on continent crust as well. So just zooming it out and asking you to understand which are the features that I have just noticed with the deep sea plain. Deep sea plain will have ridges at diverging boundary, hotspot volcanoes along mantle plume. Examples: Hawaiian Islands in Pacific Ocean, Reunion Island, Indian Ocean, and added to it. So number 1 is this, number 2 is this, and added to this, what else can be taken up into account? So slightly changing it here. What else we can take into account? Number 3, and number 3 are trenches. Trenches are developed where? Trenches are developed with subduction boundary. Subduction is when the heavier plate subduces in the warmer interiors and melts. So this is my trench right here. And if this is continental crust, there will be volcanic activity. Can we now make sense with this figure? This is my deep sea plain. Deep sea plain has got these as ridges. And what is causing these ridges? It's divergence. This divergence has resulted into this subduction. So what is this? Trench. Divergence, ridges. Convergence, subduction, trench. And some part of it can be right there as ejected out on water surface volcanic island, which can be hotspot. Is this sufficient? What is continental shelf? Continental shelf is a submerged part of continent. Why this definition actually becomes universal? Because after last ice age, there was rise in mean sea level to the tune of 200 meters. Now, if the mean sea level will rise to the tune of 200 meters, by default it will inundate low-lying areas. And that is how maximum of the continental shelves have got developed. But am I done with the characteristics that goes with shelves and slopes? No. So we get to the another figure to understand it. Please take note of this figure and understand there are certain new terms which are here. And can we notice, this is our mean sea level. So shoreline is not shown, so just don't be confused. And right here is your shelf break. That means we are on submarine location and this part is my continental shelf. And this part by default becomes continental slope, which is labeled here. Now carefully notice this feature, the submarine canyon. Actually, the submarine canyon are vertical valleys that are found both on continental shelf, you can see it here, as well as continental slope, you can see it here. And its formation actually is related to, number one, developed first and submerged later. And it is also related to turbidity currents. Basically, turbidity currents are defined to be the subsurface water currents that transports shelf deposits. That means if I take the development of submarine canyons, and you can notice that submarine canyons have got a defined depth here. If I just lightly shade it up, it will be more evident for you. These canyons results into the development of these deep fan deposits. And why these deep sea fan deposits are generated? They are generated because you are transporting huge amount of material which is deposited on continental shelf by the agents of gradation. So if you try to see the features that we can enlist when it is referred to submarine topography or submarine features, what is the list altogether applied to be? Let us go to our previous image to understand it. If I slightly zoom it up, which are the important features that I notice from the ocean feature or ocean bottom relief? One is continental shelf, two is continental slope, both can be related to submarine canyons, three is deep sea plain, and deep sea plain can be related to, number one, ridge, number two, trench, and number three, hotspots. Coming to our NCERT now, division of ocean floor. The ocean floor is divided into four major divisions. Continental shelf. The continental shelf is extended margin of each continent occupied by relatively shallow sea and gulf. The shelf typically ends at a very steep slope called shelf break. We have seen it. The width of continental shelf varies from one to another. Why? We are just coming to it. And before I take the changeover of the page, do see continental shelf, slope, deep sea plain and oceanic deeps. We are coming on to the details of each one of them. Read it out. What is continental shelf? It is extended margin of each of the continent. Number one. Number two, it is typically ending at shelf break, and number 3, its width varies from one ocean to the other. But why that is the case? Continental shelf can be 80 kilometers, in the Siberian shelf, Arctic Ocean, it is 1500 kilometers. Along the coast of Chile, it is absolutely absent. What is the reason we take continental shelves to be such variable in its depth? I repeat my case, let me use this as my quick diagram here. If I was a coastal area and there was the rise in the mean sea level, so say this was my old mean sea level during the ice age terminated and mean sea level increased. So increase in mean sea level by default, now this is my new mean sea level, so automatically this entire part will get submerged. So when I talk about width of the continental shelf, what I say, lower the height, broader will be the shelf. If the height here would have been taller, now why it is, this is my new shoreline, this is rise in the mean sea level, this was the older mean sea level, so what this will become, shelf. So why do I see shelf to be of variable width? That I can see Siberian shelf of Arctic Ocean with 1500 kilometers, and in some areas it is absolutely virtually missing. It is largely because of the height of the shoreline, because height of the shoreline determines what exactly will be the submergence. Now the another statement reading here is that the depth of the shelf also varies, 630 meters. Please remind yourself, wherever there will be, and I am taking this now, wherever there will be submarine canyons, shelves have to be deeper than 600 meters. And we have learned submarine canyons. See, this is the submarine canyons details that has been given to us right here. Submarine canyons, NCERT figure. What is missing in a clear defined manner is this. I hope you are recognizing what I have just quickly attempted. Deep fan deposit. Then comes continental slope as per our NCERT. Why it is called slope? Because it has got gradient. The depth of the slope varies between 200 to 3000 meters, has to be, because where do I place slope? Right here. So if this is my shelf break and this is my deep sea plain, this is my continental shelf, then I'll be having this part as slope. This is my break. So it has to extend from 200 meters to 3000 meters. Then NCERT reads deep sea plain, we have learned it. These are flattest and the smoothest region, largely covered with fine grain material, logical. And what is there as feature number 4? Deep trenches. We have already learned it. The trenches are where we are having subduction, and as many as 57 deeps have been explored so far. 32 are in Pacific, 19 in Atlantic and 6 in Indian Ocean. There is a point that you need to understand between the deeps and the trenches, and let me just clear it up to make you understand it. Can you recall the diagram that I attempted few minutes back, that if this is the point where the plate is subducing, so let me draw this as two continental and oceanic crust, and right here you are having subduction, right? So this all part, trench. So trench is what? Trench is a subduction zone, and if I take it 3-dimensional, it will be this. But which is the part of trench, subduction, which is the part of trench where you have reached the deepest point? That will be called deep. So this is trench and this is deep. Like this will be my mountain and this will be my peak. Similarly, this will be my trench and this will be my deep. So trench is the subduction zone, like mountain range, and deep is the deepest point of it, like a mount in a mountain. So if I say which is the deepest trench of the world, we say it is Mariana Trench. And what is the deepest point of it? It is called Challenger Deep. I hope you have understood the difference. NCERT also talks about minor features. We have seen them already. Mid-oceanic ridges where there is a diverging boundary. Atlantic ridge is an excellent example. Iceland is part of mid-Atlantic ridge. Mountain ranges have peaks as high as 2,500 meters. Some of them reaches the ocean surface, making islands, which we have seen in the diagram already. Other feature mentioned is seamount. We have understood seamount as hotspots. And see, our hotspots are Pacific, Hawaiian Islands. Seamounts basically are examples of those which have, supposedly this is my mean sea level and this is the island which is now no longer on the water surface. So if I quickly ask you to get to the image that we have seen, can you notice this? Right here. This will be my active volcano, and what are these? These will be my seamounts. Are we noticing it is below mean sea level? So this will be the example of seamount, which are NCERT reads. I'm just reshading it. Seamount. Seamount. Reason, they are no longer on the water surface, but this is an active island. Submarine canyons, we have learned it. This is a new term which I have not mentioned. Basically, any seamount which is conical and any gayout which is flat topped. Name is coming from Arnold Gayout, American oceanographer who has recognized it. So flat topped seamount. So which are the major features that I see with the ocean? So major features that I see with the oceans are continental shelf, continental slope, deep sea plain and trenches. And which are the major minor features as per NCERT? So it's canyons, it's hotspots, it's gayout, and of course it is the features that we can correlate with the mount, seamounts. This is my seamount. What is the elementary difference between seamount and a gayout? Is actually the shape. So I can call gayout a plateau. If I am calling seamount a mount, gayout can be called a plateau. So this is part 2. Now I am coming to part 3 and the final as per this chapter of NCERT. And what is that? Temperature of ocean water. We have learned temperature. I have dedicated a full video about atmospheric temperature. Just apply that. Factors that affects temperature distribution is latitude, unequal distribution of land and water. When we talk about temperature of surface water, it has to decrease from equator towards pole. The oceans in northern hemisphere receives more heat due to their contact with land, because we know northern hemisphere makes example of what? Land hemisphere. Third factor written in our NCERT is prevailing winds. The wind blowing from land towards ocean drive warm surface water away from the coast, resulting in upwelling of the cold water from below. Offshore winds facilitates vertical mixing oceanic current If Gulf Stream is warm, it by default will raise the temperature. And we can actually add factor number 5, which is not labeled in NCERT, and I'll call it continentality. Apart from all these 4 factors, sign of latitude and in boundary with the land, and then you have got the wind, prevailing wind pattern and oceanic currents, I am talking about continentality. Reason, the enclosed sea in low latitude will record higher temperature, whereas enclosed sea in higher latitude will have lower temperature. Remember, Arabian Sea will be warmer than Sea of Coast. You have to take reference of what we have learned in temperature anomaly earlier. What you need to take a general comparison is, I as Arabian Sea is a lower latitudinal water, so I'll be in the influence of what? Warmer land, so I'll have higher temperature. And Sea of a Coast is higher latitudinal water. So now applying these factors, NCERT talks about horizontal and vertical distribution of temperature. Careful. The temperature profile, temperature depth profile for ocean water shows how temperature decreases with increasing depth. This decrease in temperature has to be actually learned with 3-layer system. To make sense with this 3-layer system, let us take support of this diagram. This is for lake. Epilimnion, surface. Hypolimnion, deep. Thermocline, intermediate. Fact actually goes, and these terms are applied for lake. Lake, the lentic ecosystem. And now if I have to apply the same for ocean, what I'll do is, I'll say, this is my hypothetical water column. Surface water maximum to the depth of 500 meters will be called and deep water, because average depth of ocean water is 4000 meter, will be called benthic. It is all variation and this is all uniform. So somewhere in between I have got maximum depth 1500 meters, where there will be a separate layer which is called thermocline. All the variations in the temperature is applicable in pelagic zone and none of them is applicable in deep water. So deep water, say, temperature is standard at this level. So if I plot temperature here, I am trying to say that the surface water temperature is very high and the deep water temperature is uniform. So what will happen? Temperature will decrease with increasing depth in thermocline. And this is what is 3-layer. And notice that this 3-layer is applicable even to fresh water. Only that in fresh water we don't use the term pelagic, we use the term epilimnion. We don't use the term benthic, we use the term hypolimnion. That is the difference, otherwise we are having the same characteristics. I hope you have understood. And if I continue with the same, what I'll say, changing the color just to make it easier for us. If the surface water temperature is significantly low, then temperature will increase with increasing depth to come out to this. The first layer represents the top layer, warm oceanic water, 500 meters thick. Temperature varies. Temperature we are not standardizing. The second layer is called thermocline. 500 to 1000 meter thick. Temperature will rapidly decrease. The third layer is the cold and extend to the deep water, where the temperature can be 0 degrees or less than this. Then the factual things are there. Average temperature of important surface water of ocean is 27. It gradually decreases from equator towards pole, and the rate of decrease of temperature with increasing latitude is generally 0.5 degrees Celsius per latitude. However, we need to understand that it will vary, so the variation is being given. The average temperature is around 22 degrees Celsius at 20 degrees latitude, 14 at 40 and 0 at poles. So, you can easily remember it. We know that temperature is decreasing with increasing sign of latitude. The next thing talks about oceans in the northern hemisphere records relatively high temperature. We learned it already because we have got more of land there. So, these are the factual things that you can take into account. Conclusion of temperature goes with the maximum temperature of the ocean is always at the surface because they directly receive the heat from the sun and transmit it to the lower section of ocean through the process of conduction. The temperature falls very rapidly up to the depth of 200 meters, it decreases. I have given you that understanding already. And finally, if I have to take the another physical property as per our NCERT, it's salinity. And salinity is the term that is used to define all the total dissolved salt in the seawater, and it is calculated as amount of salt per 1000 grams. So, it comes up as parts per 1000, it is written as parts per 1000. Salinity of 24.7 parts per 1000. So, that means if it is 24.7 grams of dissolved salt per 1000 grams of sample seawater will be called brackish. And what is the ocean water salinity? It is in the range of 34 to 35 parts per 1000. So, ocean water is saline. Then NCERT mentions the factors that affects ocean water salinity: evaporation and precipitation. Higher the rate of evaporation, higher will be salinity, so positive relation. Higher the amount of precipitation, lower will be salinity, so inverse relation. Surface salinity is influenced by fresh water flow from river and also melting of ice, because they by default will be doing what? They will be diluting the salinity, so logical thing. Oceanic currents also contribute to salinity variation. Salinity, temperature and density of water are interrelated, thus change in temperature or density influences the salinity of water. Lake Van in Turkey 330, Dead Sea 238, Great Salt Lake 220, parts per 1000. Chlorine, sodium, that is the reason sodium chloride salinity, because after I take these two, I am left out with the rest of them as others. So, sulfate and etc. can easily be demarcated as others. Ocean water is considered to be the universal solvent, and we have got more than 47 different sea salts. But which of them accounts for maximum? So, it is chlorine and sodium. Horizontal distribution of salinity. Salinity in normal open ranges between 33 to 37. In landlocked water as Red Sea, it can be as high as 41, it has to be. Why the salinity levels, slightly zooming it here, why the salinity levels in Pacific Ocean, which is 35, 31 and is slightly lesser than Atlantic Ocean because of the size. And then the comparison is being given, like in Arctic region, you have got influx of melted water. In North Sea, in spite of location, higher latitude, higher salinity because of North Atlantic drift. Baltic Sea, which is at the same latitude, has lower salinity because of river water. Another comparison is being given with Mediterranean Sea. Now you need to understand that Mediterranean Sea have higher salinity due to higher evaporation. Average salinity of Indian Ocean is 35 parts per thousand. In Bay of Bengal, because of river, remind yourself, Bay of Bengal means Padma, river Ganga, Jamuna, river Brahmaputra, and then you need to recall all the major peninsular rivers of our country, Godavari, Krishna, Kaveri, and Mahanadi also are actually there. On the contrary, Arabian Sea show higher salinity because of less influx of water. And apply the same logic here, vertical salinity pattern. Which are the factors that influences ocean water salinity? It is influenced by prevailing temperature, incoming solar, redrawing it. Right. It is influenced by prevailing temperature, surface water, prevailing wind and etc. So I am again repeating the diagram which we attempted just few minutes back. So 4000 meters is the average depth, this is 500 meters, and salinity if is plotted here, and my surface water salinity is very low, it will be uniform in deeper water. So what will happen? Logical, salinity will increase. This will be pelagic zone, this is benthic zone, and this will be called halocline zone. And apply the same thing, if salinity is high, then salinity will decrease. And I surely will conclude by mentioning this, using space here. Intermediate layer of water is called pycnocline layer, which actually equals thermocline combined with halocline. 3 stratas of ocean water. Which are they? Pelagic, all variation, benthic, no variation, and pycnocline, all compensation. I think this will help you in coping up with this particular chapter. Very easy chapter, I'll not say it's a difficult one, but yes, you need to take the understanding of the 3 things that we have learned: hydrological cycle, ocean bottom relief, and also the physical properties of ocean water, that is salinity and temperature. I again repeat, take good care of your health and sit at home, study, revise. Don't delay the preparation. Happy learning. All the very best to all of you.